Hello, and welcome to our program, Astronomy for Everyone. The topic for this month's show is how our hobby of amateur astronomy has changed over the last 20 years or so. Here to talk about this topic are several of our Ford Amateur Astronomy Club members, Tim Campbell, Ken Anderson, Stephen Weddy, and John McGill. Gentlemen, all welcome to the program.
Hi, Don.
Welcome.
Hi, Don.
Well, we're going to start out talking with how we used to buy equipment, or more like where, brick and mortar stores versus the internet. And Stephen, I know that you used to go to Ryder Hobby.
Sure. Ryder Hobby was really the only place that I knew. I ended up buying a 4-inch telescope for the Warren Club from Ryder through John Kirchhoff and all of that. But in 2005, when I bought my own scope, I ordered it over the internet, 2005. So I remember before the internet, but even in 2005, I was using dial-up. That's because my internet provider was awful. I actually dumped them for dial-up. Anyway, but yeah, almost everything is internet now. I know a few people who have their own stuff, and it's you mostly only see them on the internet. So,
Right.
yeah.
I mean, some of the camera shops back in the day that used to have a telescope or two in the window, they're now all gone. Even one of our club members, Jeff Heinlein, had his own brick and mortar operation as
Sure,
well years
sure.
ago. So,
And then you also had the Orion catalog for mail order.
that too, yeah, before the days of the internet. So telescopes have changed as well. My first telescope was a manual. I had a little dial for the right ascension and another little dial for the declination, but things have changed quite a bit. And I know, John, you've got
Yeah.
your scope right behind me here.
Let me
to,
go around there.
Our viewers about that.
This is a Meade LX200, and this came out the first generation in the later part of the 1990s. And this is what brought computers to telescopes to the mainstream. And this telescope is the third generation, but what's good about it is that it costs $3,000 basically in 1995, and you can still buy the new version, which has a GPS on it and a few other goodies and it still keeps the $3,000 price tag. And of course, I had to buy this from John Kirchhoff, the enabler, and just about everybody here with gray hair or no hair has bought something from John Kirchhoff at Ryder's Hobby Shop. And yeah, so that's the new generation. Oh, one other thing about this is that this is a Schmidt-Cassegrain, and that means that it has mirrors and it bounces back and forth. And so if this was a straight telescope, this would be about 6 feet long. So this was like the all-around go-to scope to do all the different, whether you wanted to image or visual, this was a telescope that you would buy.
Yeah, we've really diversified out with the telescopes. We can even control them now with our cell phones. There are even specialized scopes that are just for astro imaging.
Yeah, so when you're just doing visual, usually you're just looking at an object in the middle. If you really carefully inspect the edges of the field, you'll notice maybe the stars aren't quite as sharp, they don't look quite as good. Just enough to drive somebody who likes to do astrophotography nuts. And so they make these very specialized scopes that are just designed for astrophotography. You can always slip a normal eyepiece on them and use them the normal way, but it's a lot of extra money to pay if you just wanted a visual scope. So they now make Newtonian reflectors that are designed for imaging. I own something called the corrected Dal-Kirkham telescope that's guarantees sharp edge-to-edge sharpness. There are refractors that have instead of just a single corrector element in it, have 4 corrector elements in it to make the images sharper.
And of course, with these newer telescopes. We've got a lot of newer equipment, both for telescopes and for binoculars, right, Ken?
And eyepieces. Okay, so this book, The Backyard Astronomer's Guide, is now on its 4th edition. It does list all the latest equipment, and if you have the older editions, you can see how it changed over time. But I'm going to be talking about eyepieces now. So we had a lot of shows where we did show eyepieces and binoculars, but one of the later technologies in eyepieces, thanks to Al Nagler, was he came up with the Ethos eyepiece, and they had 100 degrees apparent field of view, which greatly exceeded the 82-degree field of view, apparent field of view that the Naglers had. So up in the front here, I have 100 degrees apparent field of view at the 10 millimeter Ethos, 2 Explorer eyepieces, 5.5, and the 20 millimeter is a very wide and inexpensive 100 field of view. And then I really love this. This is my favorite one. It's the Nikon 17 millimeter 102 field of view HW, and it comes with an EIC that makes it a 14 millimeter. So it's like a 2-for-1 eyepiece, and they have 2 versions of that in a different size. And then we have 110 field of view for the 4.7 and the 3.7, and the bottom part makes them both a 2-inch and a 1.25 inch. Now the 3.7 millimeter eyepiece I call my globular cluster killer, because it fills the field of view with my 17.5-inch telescope, and you can split all these stars in the globular cluster, and it looks really awesome filling a field of view like that. So with the 10 millimeter eyepiece for the moon, it fills up the field of view of the moon, and it looks like you're looking at a 6-foot diameter moon just 3 feet in front of you. So it's like having a person in front and being able to see their feet and their head all in the same field of view, all in focus. Okay, and the last one I have is a 9 millimeter 120 field of view. So this is Explore Scientific, and this is the widest apparent field of view eyepiece that's out there on the market. So the next thing I have is I have the bino viewers, and on my bino viewers, these have 24 panoptic eyepieces, which are the widest teleview for a 1.25 inch eyepiece, which is needed for these type of bino viewers. And I have these power switches that have, 9 different power options, and then that's per set of eyepieces. I have a Newtonian OCS, a multiplier OCS, and multi-purpose OCS. So that gives me 3 different multipliers in the front for 27 different combinations per pair of eyepieces. Now these eyepieces are unique because these are LOA 21 millimeter eyepieces, but they're 3D eyepieces, and they give an artificial 3D field of view because one of the eyepieces has a plus pattern in it, and the center square of the plus, that enables like a +3 or a -3. So it's either very far or very distant. And then the other 2 are +2 or -2. And then the last 2 are +1 or -1. That's in like a step distance, with the background being the nominal. And then if you went and got the other eyepiece is a regular eyepiece, but it's the same power. And then Russ Lederman is able to sell a second one of these eyepieces, and you could see it without the 3D. But it does give an artificial 3D, and he also makes these binoculars which have 3 squares in it, kind of like in a line. So it'd be +2 in the center and -1 and +1 on the outsides, with the nominal being everywhere else. Then we have filter slides. So I have this for all my planetary filters that can slide in to the eyepiece. And Astrochrome has a filter slide, and this is 1/3 of it. So this is the part with the filters. So normally I have an open space, sky glow, ultra block, and O3 filter. And the third part is an adapter that enables me to use it with the bino viewers. And now Tim's going to talk about the latest technology with night vision.
Yeah, so typically if you're going to do visual observing, just an eyepiece. And so the TeleVue company has worked with another vendor, and what they've done is they've made hardware adapters that go on this to allow you to take a typical night vision monocular, and by putting this adapter on, you can simply attach this to an eyepiece of the right size, and it's now locked in place. You slip that into the telescope and use it just like a normal eyepiece, except that you get the night vision amplification.
And it's about 10,000 times light amplification. So you can, it works really good for nebulas, especially Hadron and Alpha nebulas, which are normally red, but you'll probably see everything in green. But it's very bright. It works very good with star clusters and everything. And then the same thing with the 3D eyepieces. Works really good with the Milky Way, star clusters, things with a lot of stars in it.
Anything else there on the table, Tim, to some of this new?
Well, we were going to mention the imaging. So, you know,
Exactly.
used to do imaging with film, right? And now everything is digital. Now you can still use a regular digital camera and connect it to the telescope. You take the lens off the front of the camera, and there's a little completely hollow thing. You put it on where the lens would go, and it slides into the back of telescopes over there. You typically don't need to buy an expensive camera. A lot of astrophotographers start by buying a used camera on eBay for $200 or $300 because you're going to use everything manually. So all the automatic everything that cameras come with, you won't use. But now it's kind of moved on to dedicated astro imaging cameras. So this is dedicated just for astrophotography. And if you look at this camera, you'll see there's no shutter button, there's no viewfinder, all the controls that are familiar to you. There's just a USB port on the back. And you plug this into your computer, and it is completely controlled only by software. And as the telescopes are tracking the object across the night, you have to make sure that the image doesn't smear or blur. So typically there's a second smaller scope off to the side with one of this is a guiding camera. It goes into where an eyepiece would go, and it just watches to make sure that the star doesn't drift by so much as a single pixel.
Important. But when you're imaging, we have the problem now, and we even did then, with light pollution.
Oh yeah, so the light pollution. The suburbs are expanding, and we used to have street lights that were either sodium or mercury, and we could buy filters for the camera that would block out those particular frequencies of lights that those lights emit. Now we've gone to LED lights, it's broad spectrum, so that doesn't work so well anymore. You just got to either try and shoot through it and process out the light pollution, which is difficult, or go to a darker
That's where
sky.
processing software would come in?
Yes. But the other thing that I wanted to mention about the light pollution is that you can, there are interesting techniques where the software has advanced using computer technology that does a better job of identifying when you have noise on your camera pixels and things like that to try and clean up the image.
Okay, well that's good to know that we can compensate for the ever-present light pollution in our modern society. We're going to take a quick break right here. If you have a question, please send us an email. You can check out the address down there at the bottom of your screen. And coming up next with Term of the Month is Stephen.
Thanks, Don. The term of the month is Plato. Plato is a European Space Agency mission, spacecraft with a nominal 4-year mission to look for extrasolar planets. Plato is an acronym meaning planetary transits and oscillations of stars, and also the name of a Greek philosopher. 26 cameras are now being integrated into the optical bench, which keeps them pointed in the right direction. The first camera is finished. There are 24 normal cameras and 2 fast cameras to look at more than 100,000 stars to detect planets using the transit method. For planets detected this way, the planet's size, mass, and density can be determined from dimming data. The normal cameras take data every 25 seconds. Fast cameras take data every 2.5 seconds. Camera focus is maintained by an innovative temperature-based focusing method. Changing the temperature by 1/10 of a degree Celsius changes the focus by 1 micrometer. That's 1/1000th of a millimeter. The cameras can image about 5% of the sky at once. That's just an absolutely huge amount of space. And that's because, assembled, it's a 2.11 gigapixel camera. Plato is due for launch by an Ariane 6 rocket in 2026 to the Sun-Earth L2 Lagrange point. Plato is designed to study stars between magnitude 4 and 11. These are easily studied objects from the ground with telescopes, and in fact, these stars are visible with binoculars. And that's Term of the Month, Plato. Back to you, Don.
Thanks, Stephen, and welcome back. Our topic for this month's show is how things have changed in the hobby of amateur astronomy over the last 20 years or so. We're going to pick up now talking about outreach. Our club has been involved in all sorts of outreach programs and presentations since I've been a member, which is over 25 years. But one of the big things to help with public outreach are star parties. And one of the biggest in Southeast Michigan is Astronomy at the Beach, held every September. And we've all been there and participated in it. And I know I've enjoyed it.
And I even led 2 of them.
Well, there you go. Yeah. So that's how much that we are involved with the public in that way. We've also got beginners nights that the club sponsors throughout the summer. And I know we've gone to schools over the past number of years. Tim, you've been involved with that.
Yes, we've done both bringing the kids out to look at the sun during the day. Of course, we can't do the night because it's in the classrooms. But we also do sometimes in-classroom days where we come in and we talk to kids. And whatever the education topic is, we usually coordinate that with the school to the subject matter that they need to learn.
Sure, sticking with the curriculum.
Yep.
For the teacher. And I know just this past weekend, John, we went out to Selfridge Air National Guard.
Yeah, we were out there with NASA, and we had NASA's Glenn Traveling Museum, Journey to Tomorrow. And while people were waiting in line, we had hundreds in line. We had thousands go through the exhibit, but we had our club members along the line route, and they had their solar telescopes out so that people, while they're waiting in line, could jump out of line and look through the telescopes. And that made their viewing a little more, or their wait a little more enjoyable.
Oh, sure, exactly. Plus, another way that our club has changed over the last 20 years is by the fact that you are watching this program on YouTube. We've been doing this for 15 years now, so there's a change that the club has been involved with for quite a long time. Now, another thing that has really developed over the last 20 years are software programs. And Stephen, I know you've been involved with some of that.
Yeah, well, as an example, when this show started in 2009, I was using a program called K-Stars for the What's Up segment. And K-Stars is a planetarium program, and it's free and all of that stuff. I might have used Celestia, which was also available at the time. But I have almost entirely moved to Stellarium, which does, has the feature that it looks more like it's more realistic looking. It's not a chart so much as it's what you might see. And, that's a big difference.
It is. It looks like what you could see in a planetarium.
That's right.
And we use that for What's Up.
And What's Up now uses that, yes.
Yep, exactly.
There was also the switch from the old NTSC TV to HD TV, which for us happened in 2015. So that's 10 years ago almost.
Yeah, yeah. So those are some of the changes that we've seen. Also, cell phone tech.
Now the software is on the phone, right? So
Right.
instead of actually having it on a PC, now you can have it on your phone. I recall when I started, atlases of the night sky to find where objects were printed on paper. Typically things down to maybe 8th or 9th magnitude, but I had a huge library reference that had everything down to 11th magnitude. It weighs more than 10 pounds. Now I have everything down to 18th magnitude on my phone. I would probably need a book that would weigh more than 100 pounds if I wanted to do that. So it's amazing what you can do with just a phone.
Yeah, also with the cell phone, back to my computerized telescope there, I have a program on my cell phone where it shows the sky and I can just touch my phone and that will communicate with my telescope and that will take it right to where I pictured right on my cell phone. And another thing with cell phones is when we are out doing public outreach and say we're looking at Jupiter and there's the moons of Jupiter, we might see 2 or 3 moons of Jupiter, and off the top of my head I wouldn't know what moon that is, and then someone from the audience or one of the junior observers that are just coming to look through our telescopes, they'll look on their cell phone and they'll tell me, oh, that's that moon or whatever.
Yeah, the
And
program's
prior
working.
to that, you had to use the magazines, which had the sine cosine
Or remember Sky
curves.
Scout? We used to
Yeah.
have Sky Scout before we got the software programs on
Or
phones.
the planisphere that we used to
And
twirl.
the cell phones can also have your eyepieces with the true field of view, and it shows how the object would look for the different types of eyepieces and telescope that you have. But it doesn't show the magnitude difference. It only shows the size and the geometry in the eyepiece view.
But just thinking about what we were just discussing, just how much that has changed since we got in the hobby, 10, 15, 20 plus years. So we won't go any farther back than that. So, but I think one thing that's important, not only for our hobby, or our club, I should say, in the hobby, is the membership, and especially looking to find younger people to come in. On this show, you've seen a lot of gray hair, and so that's one of the things we want to do is bring younger people into the hobby.
Yeah, I think the cell phone technology, I think
That's appealing to young people?
that's appealing, and with being able for them to take pictures of the night sky with their cell phones, I think that is where they're at, what they're thinking about.
And it seems that a lot of females are coming in to join our club. Teachers or people that are just getting into the hobby with the computer imaging and stuff like that.
Exactly. Well, this has been a great conversation. At times I wish we had an hour program, but we don't. So I do want to thank all of my guests, our fellow club members, for sitting in today to talking about the changes in the last 20 years. Please visit our club website. The address is down there at the bottom of your screen. And coming up next to round out the program is Stephen with What's Up in the Night Sky.
Thanks, Don. What's up in the night sky for July 2024? Now, we just had the solstice, whether it's the southern winter solstice or the northern summer solstice, it's still a solstice, and the days are changing their length slowest for the year. The moons start with a new moon on the 5th, first quarter on the 13th, full moon on July 21st, which is almost a supermoon because perigee is only 3 days later, and then last quarter is on the 27th. Then we have Mercury and Venus just after sunset. Mercury goes from Cancer to Leo and sets about an hour after sunset to half an hour of the sunset, the half hour after sunset by the end of the month. It's better at the beginning of the month. Max eastern elongation is on the 22nd, so that is also a pretty best day of seeing Mercury. Aphelion is on the 27th, which means that Mercury is physically farthest from the sun, so it's also a little bit farther in the sky from the sun. And then we have Venus, which goes from Gemini to Leo, so they're both in Leo, and sets a half an hour after sunset, so it's a little closer. Then we have Jupiter, Uranus, Mars, Neptune, Saturn, and Pluto, all in the same thing. Now, you would be looking at most of these objects, say, later after midnight rather than closer to the sun, which is in the morning where it's shown. I just wanted to get them all in the same view. Mars goes from Aries to Taurus and rises, 3 a.m. to 2 a.m. local time, something like that. Jupiter is also in Taurus and does more or less the same thing, just a little bit later. Saturn is in Aquarius and rises, I would say, local midnight, and then to 10 p.m. by the end of the month. Uranus is in Taurus also, and but it rises later, but it's early in the morning, so it's after midnight. And then Neptune is in Pisces and rises earlier than Uranus does, so sort of 1 a.m. to 11 p.m. Pluto is in Capricornus, and it rises before midnight all month. It is best sort of local 3 a.m. to 1 a.m., and it's best at the end of the month, especially because opposition for Pluto is on the 23rd of July. So if you've got a 12-inch telescope or larger, and if you've got a really good sky chart, this is the best time of the entire year to look for Pluto. And that's what's up in the night sky for July 2024. Now remember, we don't charge money for this show, but we may tax your brain.